Hello everyone, Sonal Palve here, and let's continue our course with our next topic, linked list and its types. So from here onwards, we are going to study the real data part. We are going to dive into code and much more. So what is linked list? A linked list is a sequence of data structures which are connected together via links. Or in a simple word, you can say linked list is a sequence of links which contains items. For example, train. Have you ever seen train like this? Here, each buggy is linked with the another buggy. For example, this buggy is linked with this. This one is linked with this. Likewise, in the same manner, linked list contains node and each node is linked with another node. Now let's focus on the parts of linked list. So, the element in a linked list are linked using pointers. Why? I will tell you. First, look at the second point. In simple words, a linked list consists of nodes where each node contains a data field and a reference link to the next node in the list. What does it mean? It means that linked list is consist of node. And what node consists of? Node consists of two parts. This is a node. It consists of two parts, and the first part is data part. The second part is next part. So what this data part is going to do is it will hold the variables to be stored. And this next part in the node is going to hold the address of the next node. This is how linked list works. It has several nodes and each node consists of the next part which holds the address of the next node. For example, these are the four nodes. This is a linked list which contains four nodes. These are the nodes where two parts are present, one data part and one next part. So each node is having one data part and next part. These are some values we want to input in linked list. 10, 12, 67, 34. So let's give each to each one. 10, 12, 67, 34. Now the data part is full. The very first node in the linked list is also called as start node. This is the first node and called as start node. It has its own address. Let's assume it is 650. But what do this next part is going to hold? It will hold 720. This is just an assumption, okay? What is 720? 720 is the address of next node. And likewise, in the same manner, further nodes also work. This will hold 800. Why? Because 800 is the address of next one. Now, the third node will hold the address of fourth one. This is 850 and 850 is the address of fourth node. And as you can see, there is no more nodes further available. So the last node will just set the address part as null because it's not having any kind of node further of which the address could be held. This is how linked list works. Now let's have a look on some points on linked list. The first point is linked lists are dynamic and flexible and can expand and contract its size. Why? Because in linked list, memory is allocated dynamically, that is during execution time. Yes, because linked list is flexible so that it can expand or contract its size according to the situation. And this only happens in dynamic memory allocation, which we have seen before. Here elements are stored randomly and space is required to store pointers next to nodes. So we will see this by using examples. Operations performed on linked list are insertion, deletion, and traversing. Let's take an example of this linked list, which contains 4 nodes in it, having 2 parts, one data and another one is next part. So it consists of some value stored in it. This is the start, means this is the first node in linked list, which is also known as start, having its own address as, let's say, 650, and its next part is holding 720, which is the address of the nextmost node. Likewise, in the same manner, each next part of the nodes are holding the addresses of the next node. So elements are stored randomly means, look at here, 650, 720. These are some addresses at which the nodes are present. But let me tell you that these addresses aren't contiguous. It means they are random. Although it consists of an integer data, that is 10, 20, 30, 40. These are the integer values stored in it, but then also the memory is not contiguous. This is the speciality of linked list, that in linked list elements are stored at random memory addresses. Space is required to store pointers next to node, because node consists of 2 parts. It does not only holds the value, it also holds the addresses of the next node. That's why space is required to store pointers next to nodes. Insertion of a node. For it, you have to first create a node, and then this node is to be inserted into linked list by 3 ways. Either you could insert this node into linked list at the end, or at the beginning, or at the middle. So there are 3 ways to insert a node, and also there are 3 ways to delete a node. You could either delete the first node, or the middle node, or the last one. And traversing. Traversing means dragging, and you could say that it's like searching the nodes. The nodes which to be inserted, the nodes which to be deleted are first traversed or are first searched, and then these operations are performed on them. Hope you understand. Now, moving to the next, there are certain types of linked lists. First one is singly linked list, next one doubly linked list, and circular linked list. So what is singly linked list? Singly linked list contains nodes which have a data field as well as next field, which points to the next node in line of nodes. This is a common definition just we have seen. It simply says that singly linked list is something which contains the nodes, and the node has 2 parts. The one is data part and the another one is next part, which we have seen before. So moving to the further, what we are going to do is we are first study to how to construct a linked list. It basically means at the first you have to create a node, and on that node we are going to do certain kind of operations such as insertion, traversing, and deletion of node. Now here we will study the actual code of constructing linked list. So what we are going to do is we are going to construct a linked list, but before constructing linked list we have to construct a node. So these are some points which we have to remember before constructing the node. At the first, we have to construct the structure of a node. So let me tell you what structure of node is actually. as we know, our node is consist of one data part and one next part. So data part will be of integer data type and the next part will be the pointer, because pointer is only the one thing which can hold the address of another variable, right? That's why my structure will be consist of integer data type and one pointer. So at the very first I will use struct keyword and I will define my node. I will at the very first struct node in curly brackets int data, and the second part is the next part, which I will write like this: struct node asterisk next. Now why I have taken struct node asterisk next? The reason is very simple. Next part is going to hold the address of another node, means it is going to hold the address of whole node, not just the address of variable. That's why I'm using struct node asterisk next. Now our structure is ready. After that, what I'm doing is struct node asterisk next. As I told before, we are going to construct, one second, asterisk start equals to null. So as I told before that we are going to construct a linked list, means it is not having a single node in it at a moment. So this start is the first node and start holds the address of the first node. That's why I am explicitly mentioning that struct node asterisk start equals to null. So what this will do, this will set the address of start to the null. Now the actual game begins here. Void insert. I'm creating one function insert, and the name itself, which will be giving you idea that what this function is going to do. It will insert our node. But before that, we are going to make ready our node. So struct node asterisk temp. Now the first step is over. We have constructed the structure of node and also the name of our node will be the temp. The next part is we have to allocate memory to the node. So this I am doing with malloc temp equals to struct node asterisk malloc size of, one second, size of struct node close. So what this temp will do, what this code will do, this will allocate a memory address to temp. Now memory allocation is done and at the last we have to set the pointers. But before that, what I will do is I will give a quick message to my users that please enter the value to be inserted. Now my user will get that he or she have to insert the value. Now as soon as my user will insert the value, I'm going to accept it through scanf and I will store it into the temp of data. What do this represents temp of data? It represents that the value which user are going to insert is to be stored into the data part of temp. Now I will set the pointer to null. Which pointer? Temp of next equals to null. Now the reason is very simple to do this, because this is temp, this is node which we are going to create. Let's say 56 is the value which the user has inserted and we have stored it into the data part of the temp. But have a look on this 900 and how do this 900 came here, because as you know that we have dynamically allocated memory to node, at that time what malloc do is malloc give a temporary memory address to temp, that is 900. So as soon as you allocate memory to node dynamically, at that time 900 address is given by the malloc function to temp. That's why what I have to do is this temp at the time, at the moment, isn't the part of linked list. That's why I will set temp of next equals to null, as there is no node present in front of temp of whose the address could be hold. Right now we just made the node and now it's time to do some operations on it. So at the very first we will try to insert a node, and these are some points to remember while inserting a node. So at the very first, you have to check whether the linked list is empty or not, because on that condition, we are going to decide whether we have to insert the node at the beginning or at the middle or at the end of the linked list. So for example, a water sprayer. Have you ever seen a water sprayer? We just sprinkle the water from it like this. So how does it works, this water sprayer? You know that the below container, that container, we have to first fill it with water. But before filling it, you first check whether the container is full of water or it is empty. And on that basis, you decide how much water you have to input in it. Likewise, also in a linked list, we have to first check whether the linked list is empty or not. Why? Because if it happens that linked list is already full and still you are trying to insert the nodes into it, then the condition will occur where overflow is there. Means the water will start flowing out of the bottle. Likewise, the condition will occur in linked list where the overflow is in process. And you can't pour water into it, right? So likewise in linked list, if it is found that there is no empty space or memory is there in a linked list so that we could insert a node into it, so at that time the overflow occurs if we still try to input or to insert the node into it. That's why remember this point, first you have to check whether the linked list is empty or not. So basically there are three types of insertion in linked list: insertion at the beginning, at the middle, and at the end. For understanding these types of insertion, let's have a look on one example. For example, a new student enters a class of 50 students. This is a student which is going to enter a class of 50 students, and now the teacher is in dilemma of which roll number should be plotted to this student. So what the teacher will do, teacher will either give him the roll number likewise like 1 or between 1 to 50 or after 50, that is at the end, that is 51. Likewise in linked list also you can insert a node at the beginning or at the middle or at the end. For example, teacher is giving roll number 1 means it will be acting like a insertion at beginning. If teacher is giving roll number between 1 to 50, that is 35, then it will be like insertion at the middle in linked list. Now let's compare the roll number 51. So if teacher gives 51 roll number to the student, so it could be like insertion at the end of the linked list. So likewise, in comparing these two examples, hope you got the idea of how the insertion at beginning, middle, and end works. So at the very first, we have seen the code to construct the node. Now our node is ready to get into this linked list. So now we will perform the insertion of node into this linked list. For that, the very first condition which we have to remember is first we have to check if the linked list is empty or not. So how we will check it? If start equals to null. then what it will happen, it denotes that the linked list is empty. Why? Because start is the first node or the address of the first node in a linked list. But if it seems to be null, it means that linked list is empty. And the next part, in the next part, what we will do is start equals to temp. Why? Because if it happens that the linked list is empty, it means temp will be the first node which is going to be inserted into this linked list. That's why start equals to temp. Means at this time, temp will play the role of start if the linked list is empty. Remember. Now let's have else part into it. Else. So what will be there into else part? Else part defines that if this condition fails, it means if the linked list is not empty and it has some nodes present into it already. So what we will do, there two condition arises. Either you could insert this temp in the middle or at the end of the linked list. So first tell me, when you will insert this temp at the middle of the linked list, which nodes are getting disturbed? I think, let's say after 33, I want to insert this node whose data part is 56. Obviously, the two nodes are getting disturbed. The first one is the node having data part 33 and the next one is the node which having the data part of 45. So to deal with them, what we will do, we will take one integer info. Now what this info is actually, I will tell you. But in linked list, we don't have control over the addresses, but we have the control over the data, because data is one part which we are going to insert into it of our choice. So info is such a kind of integer after which you want to insert a new value. I will give a message to my user that enter the value after which you want to insert the node. Here spelling of enter code. Yeah. So I have gave the message to my user that he or she have to enter the value after which you want to insert the node. Means my user could also give the value such as 33 or 45 or 50 or 23. Those value I am going to accept through scanf and I am going to store it into info and info. Okay. Now my info is having some value. Let's say my user entered 33. It means that after 33, this temp I have to add. I mean to say I have to insert. So, but this is 33. We know the value, but how could we reach up to this node? So at this time we have to use traversing, or you can say we have to drag one node till the info part, that is the data part of a node, doesn't matches to the info. Means what we will do, we will take one more another node. I will declare it here in the else part. Struct node asterisk r. I will take asterisk r is another node which we are using to search out such node after which we are going to insert this step. Okay. So now asterisk r. What we will do, we will first start this asterisk r. First we will start r equals to start. It means to say that now our r is here. 1 second. So our r is here. Yeah. Now our r is here at the moment. As soon as I coded as r equals to start, I added this line to my code. So what happens? R is declared here, and this node will be named as R right now. So where my R is pointing, my R is pointing to 720. That is the address of the first node. Now we have to drag this R. Means we have to shift this R from one node to another node, and this dragging will not end up to the data part of the node doesn't matches with the info part. That is with this info. So how we will drag? We will simply use R equals to R of next. 1 second. R equals to R of next. Means this is R. With what is R of next? 750. Now again it will drag. First we have to use the while condition. This is while condition, and in while condition, up to which condition we have to drag? Up to the data part of a node doesn't matches with means does not equals to info. Hope you are getting what I am trying to tell you. Now I have written the while condition. Now what I am doing is I am starting my dragging r equal to r of next. R equals to r of next. Now this dragging will continue until this data part of R doesn't matches with info. And if it matches, now let's say my R will come here. What is the data part? It is 33. It is matching with info. Okay. Now it will exit the while. So up till now we have found that first node which is getting disturbed. Now it's time to find the second node which is getting disturbed. For that, what I am doing is I am defining one more struct node asterisk yes here, which will be our second node which is getting disturbed. But wait, if you will notice here, the next part of the node of R is getting disturbed, because what is R of next? It is 800, and 800 is the address of the second node which is getting disturbed when we insert temp into it. So we could write here like S equals to R of next. Right? Means this is the second node which is getting disturbed. This is the first node which is getting disturbed. And we have dealt with the both nodes. Now what we will do, as soon as this temp is inserted in between this, the next part of this R goes to temp, and the next part of the temp goes to S. Right? Means what happens here? Suppose this temp will be here now. 1 second, I'll tell you. Here the temp will be there. Now look at this diagram carefully. I'm trying to tell you what's happening over here. This is 900 will be here. Yeah. This is 870. Now what will happen as soon as this temp is going to insert between these two, the next part of the R. This is R, right? We have got R, we drag this R. No, 1 second. Yeah. So what we were doing is we have dragged this R and now the R is here. So this is R, this is S, this is the next part of the R and this is the next part of the S. So what happens here when we insert temp into it? The next part of the R goes to temp, right? Means here 800 will come instead of 870. Now this is the memory which was we allocated previously dynamically through malloc. Now what will happen to it? At this memory, S, this next part of the S will be there. Means temp of next will be the S. Getting? Hope you got what I am trying to tell you. I'll erase it. Now, the last thing which we are going to do in this code is only that we are changing the place of R of next, which will be temp, and temp of next will be S. That's it. Now our code is ready. This is the whole code for inserting this node into it at the middle and at the beginning. Now we have deal with it. So like in insertion of linked list, we have seen some points to remember. Now we will see some points to remember for deletion of node in a linked list. So deletion of linked list. For example, and water sprayer. The best example is water sprayer because you know that this water sprayer needs to fill first, then only it works and it sprinkles the water. But what if the water sprayer is empty already? And still you are trying to push this node to sprinkle water. What will be the result? The result will be nothing. Water will not come out of this sprayer. Why? Because this water sprayer does not consist of any water. It is completely empty. So only air will be thrown out of this. And this condition could also be called as underflow. In the same manner, in linked list, if there is no node present in linked list and still you are trying to delete nodes into the linked list, then the condition will occur whose name is underflow. And basically there are also three ways of deletion. Deletion at the beginning, deletion at the end, and deletion at the middle. So these are some points which you have to remember. First, while deleting nodes in the linked list, what you have to do is you have to again check if the linked list is empty or not. So right now we have dealt with the insertion of the node. Now we will deal with the deletion of the node. And you know, likewise in insertion, in deletion also there are three types of situation. Either you could delete the first node or the middle one or the end one. So let's get into the code. At the very first, name the node which we are going to delete, that is struct node asterisk temp. Temp will be the node which we are going to delete. Before deletion, we are going to check the condition that if temp equals to null. What does it mean? If the linked list is empty or not. If it happens that linked list is empty, then what I will do, I will give a message that printf linked list is empty and hence you cannot perform deletion operation on it, right? After that, what I am going to do is in the else part, I am going to print that if what else part denotes is that this condition is false, that linked list is not empty. So what will happen if linked list is not empty? If linked list is not empty, then we are going to give on the value to be deleted. One second. Enter the value to be deleted. Now, for storing that value which user is giving to us, here I am going to define int info. Now int info is declared. After that, I will accept that value and I will store it into info, right? Now what we are going to do in the next attempt is we have to find the node whose data part matches with the info, because info is the one value which we are going to which we are supposed to delete. So first we will start the temp equals to start. Now after starting temp, what we are going to do is we are taking a condition in while that data part of temp does not equals to info. And what we will do in while part, we will keep dragging this temp equals to temp of next. So this dragging will be continued till our data part of temp does not matches with the info. Hope you are getting. So after that, now where our temp is when our temp will be here when we start the temp. At temp equals to start, temp will be at the first node. And when we are giving a condition in a while loop that temp of data does not equals to info, this temp keep dragging until the data part of info does not matches with the info. Data part of temp does not matches with the info. Now, if temp equals to null, what does it mean? If temp equals to null, where this temp, where the next part of the temp is going to be null, here at the last node, right? If it is found that user has choose 50 value to be deleted, so it means that it is the last value, means temp will be present here. So what we are going to do here, if it is found that it is the last node, then print f %d is deleted, right? And what is %d? %d is the data part of temp. I guess you are getting it right now. Now tell me, if I deleted this 50, if I deleted this temp 50, what will happen? This 850 will be the last node and it will be set to null, right? So this is the node which is getting affected after the deletion of the last node. So we have to find this node now. How we will find it? We will use, what we will do is we will take one more node asterisk r, let's say. And what will be this int asterisk r? This int asterisk r will be the node which is getting affected when we delete the last node. After that, we will start r now. R equals to start. Now, again take the while condition, and what will be there in while condition? R of next, r of next does not equals to temp. What do this mean? Means that what is r of next? It is temp. That is, the next part of the r is temp, and this is only the one node which is getting affected after the deletion of temp. So we got the node which is getting affected after the deletion of temp. And we will keep dragging. No, right. Till r of next does not equals to temp, we keep dragging r equals to r of next. Now, as soon as we got r of next equals to temp, r will exit this while loop, and what will happen? We have to explicitly mention that r of next will be null after the deletion of last node. So we corrected the error now. We corrected the affected part now. As we set the r of next equals to null, we are also supposed to set temp of next equals to null. Now why? In previous lectures, we have studied the concept of dangling pointers. Yes, as we are deleting the node means we are freeing up the memory, and after memory gets freed up, you know that dangling pointers are formed there. So to avoid the dangling pointers to be formed, what we are going to do is we are setting the temp of next to null, so that now we have seen how to do deletion at the end. Now we are going to see how to delete node present at the beginning. So we will take else if part here. Else if, and what my else if is consist of? If, one second, else if temp equals to start. Temp equals to start means temp is here. Temp is at the beginning. What temp is? Temp is the one node which we are going to delete. It means that we are going to delete the first node right now. So if it happens that temp is the starting node, we are going to print that, printf %d is deleted, and what it will be? Temp of data. Temp of data, right? And then we will drag this start. Start equals to start of next. Now, as we drag this start equals to start of next, also we have to set temp of next as null. Why? Again, the same situation to avoid the dangling pointers here. Start equals to start of next and temp of next equals to null. What do this start equals to start of next means? Means that after the deletion of this temp, this node is getting affected. What? This is going to hold the address of this node, and this is going to hold the address of next node. But listen carefully. Now after the deletion of this temp won't be the part of linked list, and that's why the start will be this now after deletion of this temp. Remember. Now let's move further and let's see the condition. If it is not the starting node, it is not the ending node, it means that we are going to delete the node which is present at the middle. So what happens if I have to now, yeah, I have to delete this 45, the node consisting the data part 45 here. So these two nodes are getting affected, right? This one and this one. So for finding one more node, for finding the first node, we are using one R node, and for finding the second one node, we are using the S node, right? Like we have done before. So let's get into the code and understand this last part of deletion of code. Yeah. Else printf, what I'm going to print is that printf on new line %d is deleted, and what it is the data part of temp of data, right? Now s equals to start. Okay, for finding the second most node which is getting affected, what will be there here? S. As soon as I write this line into my code, s equals to start, my s is here. Now, one second. Yeah. While, I will take one while condition. While s of next does not equals to temp, then what will happen? If this s of next is not temp, keep dragging until we get the s of next equals to temp. S of next equals to temp. S equals to s of next. Yeah. So this dragging will continue till the next part of the s does not equals to temp. Means first s will be here. Now s will be here. But this is not the one node which we are going to delete. So again drag this s. Now s will be, one second. I have to use eraser. It is completely looking messy. Yeah. Now s is here, and you could see that the next part of s is temp, because temp is present over here, right? This is the one node which we are going to delete. Now we have got the s. As soon as s of next matches with temp, s will be out of this while block, and s of next will be the temp of next, right? S of next will be equal to temp of next, but the temp of next is getting freed up, its memory is getting freed up. So again we have to explicitly set it to null to avoid dangling pointers, right? Now the code is finished. Free my temp. That's it. Hope you got the whole code, the deletion and the insertion of the node. Here we are on the codeport.io IDE, where I'm going to show you how linked lists work. So this is the whole program of linked list we have just seen. What I have done is I have taken all the functions in one program, that is word insert, and we have seen whole code this in detail. Then void del function also we have seen. In this function we are going to perform deletion of node. Yes, only the one extra point which I have added here is void display, in which the the node which is getting inserted or which is getting deleted will also be displayed. So in that, simply I have just taken one node which is temp. If start equals to null means we are going to check whether the nodes are present in linked list or not. After that, if it is found that node is empty, so I will print that linked list is empty. And in else part, if it is found that there are nodes present over in the linked list, then we are going to display it. So how we will display? First we will start the temp, then while temp does not equals to null, it means that while temp does not equals to null, this loop will continue till the last node, and it will print temp of data. That is, it will display the data part of the temp. And this dragging will keep going on until this while loop, this temp does not reaches to the last node. So let's run it. Now it is showing that compilation is successful. So we are going to run this program. First it is asking to enter my choice. That is, I will insert 1. That is, I have to insert in it. So which value I want to insert, it is asking to me. So 23, enter. New value inserted is 23, right? Now again I want to insert. I entered my choice, enter value to be inserted. So I want to insert 67 into it. Now enter the value after which you want to insert a new value. Now what is this? We have defined one info integer there. So it is asking the value of integer here. So after which value I want to insert a new value. After 23 I want to insert a new value. So now 67 is inserted. We will perform insertion one more time, then I will show you how deletion is performed. Enter value to be inserted, 34. And after which value I want to insert this? After 67 I want to insert this, because previously inserted value was 67. Okay, 34 is inserted. Now I will perform deletion. So which value I want to delete? Suppose I want to delete 67. This is deletion in the middle, okay, because 67 stands between 23 and 34. 67 is deleted. So hey guys, thank you so much. I'll see you in the next class.